Hey guys, and welcome to the video tutorial. This is the video tutorial for solving challenge problem number 2, and we're going to be doing scenario 2. So here is our setup. If you recall, we had an angle theta, we had M2, and it was attached to the pulley, and hung from the pulley was M1. And in scenario 2, we had to come up with an expression for the mass of my hanging block, but now we had friction to contend with. And we had to give our answer in terms of M2, theta, mu s, and any other fundamental constants. Really, they could have said M2, theta, and other fundamental constants, meaning that mu s and g are my other two fundamental constants. Okay, so I'm going to draw this a little bit bigger so that way we can kind of see our setup a little bit better. So here's M2, pulley, and there's M1. Okay. Now, if we remember, the amount of static friction is mu s times Fn, where mu s was my coefficient of static friction. And that depended on what two surfaces I'm talking about. Okay? So, again, the goal is to figure out M1. Well, if I draw a free body diagram for M1, here's the weight of block 1, which is equal to M1G. And I know that that tension force is equal but opposite to that. And I know that this tension force is equal to this tension force. So that's what enabled us to solve scenario 1. Now, both of these blocks are again in equilibrium. So I'm going to draw this object's weight, which is just mass times gravity. I've got my normal force coming off like this. And now I have a static frictional force that I have to deal with. So if tension is pulling this block up the ramp, then static friction is keeping it there by working against the tension. So static friction is actually pulling down the ramp. Okay? So, again, I'm going to work with block 2. And I know that it's in equilibrium, so the sum of all my forces in the x direction have to equal 0. Well, now, what are my forces in the x direction? Well, I have my force due to tension. I have my frictional force. But I also have my x component of my weight. All of those three forces added together need to give me 0. So, my x component. There I am drawing my axes, and my x component is this line right here. That is FGX. And I know that this angle is theta because this angle is theta. Remember, the angle from your y-axis out to your weight vector is always theta. Okay. So I want the x component, which is the opposite. So katoa, I'm going to use sine. So FGX is FG2 sine of theta. Now, what is FG2? Well, I just wrote it right here. It's M2G. So FGX equals M2G sine of theta. Okay. Now, my tension force, we had already said, because block 1 here is in equilibrium, that those two forces are equal but opposite. Okay, so here's what I'm going to do. Because block 2, tension is moving in the positive direction, I'm going to say that it is positive, and it's M1G. Static friction is negative because it's pulling down the ramp. So I'm going to go minus mu s times Fn. And then my x component of my weight is also negative because it's going from the axis back in the negative direction. So I'm going to go minus m2g sine theta. All of that needs to equal 0. So I've got everything pretty much in the constants that I need except for normal force. I need to figure out what normal force equals. To do that, I'm going to have to sum my forces in the y direction. The only forces in the y direction, again, we're working with block 2, is normal force and FGY. And we already know what FGY is. I'm going to skip a step here, it's m2g cosine theta, because it's FG2 cosine, and I replaced FG with mg. So, because it's moving down, the weight is moving down, I'm going to say normal force minus m2g cosine theta. And now I can add that to the other side. Plug that in for my normal force. And I'm left to solve for m1. So if you look, all of these terms have a gravity. I can cancel that out, add both of those to the other side. Oops, m2 sine theta. Both of those have an m2, so I can go m1 equals, I pull out an m2 times mu s cosine theta minus sine theta. If you didn't simplify it like that, that's fine. But that would be your final answer.